Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will be discussing pointers in C++. Now, as we all know, pointer is a derived data type. Now, associated with pointers, there are three important concepts. These are pointer constant, pointer value, and pointer variable. Now let us try to understand what is pointer constant, what is pointer value, and what is pointer variable with the help of a very simple diagram. Now here just see in this particular diagram I have a variable var1. Now it is declared as an integer variable. So when a variable is declared, memory allocation is done to that particular variable. So here 0x123 is the memory allocation that is done to the variable var1. Now, in case of high-level programming or middle-level programming, you are not allowed to work with the absolute address of the variable. That means you're not allowed to work with 0x123. So instead of that, what we do is we work with a logical version of the physical address that's called as pointer value, which is obtained using an address operator ampersand along with the variable name. So now, since you're not allowed to work with the physical address, so you use the logical version of the address. Now that logical version of the address is being initialized to a pointer variable ptr. So here ptr is a pointer variable that is capable of pointing to a variable of type integer. So here int star ptr does not mean that ptr is of type integer. It implies ptr is a pointer that is capable of pointing to variable of type integer, which means here 2 bytes of memory is not allocated to ptr. Okay, so memory allocation for pointer depends on the type of system or type of architecture that you're using. So here it simply implies ptr is a pointer that is capable of pointing to variable of type integer. So since ptr is capable of pointing to variable of type integer, so it can hold the address of var1. So here 0x123 is called as the absolute address of the variable var1, which is also called as pointer constant. Since you are not allowed to work with the absolute address, you use the logical version of the address, that is using the address operator ampersand. So ampersand var1 will give you the pointer value, and ptr, that is capable of holding the address of an integer variable, is initialized with the value of the address of var1. So ptr becomes pointer variable. Okay, so these are the three important concepts. So pointer constant basically refers to the absolute address of the variable, pointer value refers to the logical address of the variable, and pointer variable is a variable that is capable of pointing to or holding the address of another variable. So that is what we have elaboratively explained here. So pointer constant. So pointer constant is the absolute address associated with the variable. In the above diagram, 0x123 is the absolute address of variable var1. Likewise, 0x155 is the absolute address of the pointer variable ptr. Now, pointer value. So in case of high level and middle level programming, we cannot use the absolute address, or does not allow the use of absolute address. So an alternative form of address is used in order to refer to the address location called as the pointer value. So this can be achieved using the address operator ampersand along with the variable name. So example ampersand var1 ampersand ptr. Now likewise pointer variable. So these are variables that holds pointer value. That means it's capable of holding the address of another variable. So pointer variable can be initialized with 0 or null or pointer value or content of any other pointer. But we need to ensure that the type of both the pointers are same. So we can have ptr being initialized with a pointer value, that is ampersand val1, or null or 0 or another pointer of same type. So These are the three important concepts that you need to always remember in context to pointers. So you need to understand what is pointer constant, you need to understand what is pointer value, and you need to understand what is pointer variable. Now let us try to understand pointers and simple variables. So let's try to take an example. Let us try to understand how pointers can be used in connection with simple variables. Now here just see, I have my main function. In the main function, I have declared a variable by the name var, and var is being initialized to 20, and I have declared a pointer ip. Okay, right? So integer star ip. So here star is memory dereferencing operator and ip is the pointer. So this is the way how we declare a pointer. Now ip is being initialized with the address of var, right? IP is being initialized with the address of VAR. Now, what I have done is I've displayed the values of VAR using the variable name. Now, this is called as direct memory access. So I am accessing the memory with the name of the variable. And here what I'm doing is I'm printing the address of VAR using IP. So since IP is holding the address of VAR, right? Okay. So here I'm printing the address of VAR through IP. Then I'm printing the value of VAR using IP. So in order to print the value of the variable whose address is being held by the pointer, we use the dereferencing operator star. So this is called as memory dereferencing operator or indirect memory access. So this is the way how you can access the value of the variable whose address is being held by the pointer. So in this particular example, I have taken a very simple variable, right? And the variable is initialized with value 20. Then I've declared a pointer. Then the address of the variable is initialized to the pointer. Then we have printed the value of the variable using direct memory access. And then we have printed the address of the variable using the pointer variable. And then we have printed the value of the variable using the pointer variable. Now, this is the way how we can use a pointer variable. Now, let us try to understand pointers and arrays, right? So in case of an array, please listen to me carefully. In case of an array, array name itself is a pointer value, right? Array name itself is a pointer value that marks the beginning of array definition in memory. So this is very much important for all of us to understand. In case of an array declaration, the array name itself is a pointer value that marks the beginning of array definition in memory. That means if you print an integer equivalent of the array name, it will give you the base address of the array. Now consider a declaration array a underscore a 10. So here what I have done, I have declared an array by the name arra underscore a, and the size of the array is 10. So here 10 into 2, that is 20 bytes of continuous memory location will be allocated to arra underscore a, or 20 continuous bytes will be allocated to this particular array. Now here in this declaration, arra underscore a itself is a pointer value that marks the beginning of array definition memory. That means arra underscore a itself is a pointer value that marks the beginning of array definition memory. So if you print an integer equivalent of this, you will get the base address of the array. Now further, this value can be initialized to a pointer. Now here what I've done is I've declared a pointer ptr which is capable of pointing to variable of type integer, right? So ptr is now getting initialized with arra underscore a. So since I've said that arra underscore a itself is a pointer value, so this pointer value can be initialized to ptr. So now in order to access the ith element of the array, we use the notation arra underscore ai, right? So in order to access the ith value of the array, what do? Is we use the notation arra underscore ai. This is direct memory access. Now using the pointer notation, it will be replaced with asterisk of ptr plus I. So here PTR is equated to ARR A underscore A. That's the base address of the array. So here ARR A underscore AI basically refers to value stored at ith displacement from base address ARR A underscore A. Right? The meaning of ARR A underscore AI is value stored at ith displacement from base address ARR A underscore A. Now likewise here, since now PTR is being initialized with ARR A underscore A, so ARRA underscore AI basically refers to value stored at ith displacement from the base pointer, that is PTR. So it is as equivalent as that of writing ARRA underscore AI. So in order to access ith element of the array, either you can use the array notation or the pointer notation. But the meaning of both the notation, that is the array notation as well as the pointer notation, is same. That is, you are trying to access ith element from the base address of the array. So, which implies in case of one-dimensional array, to access ith value of the array, we can use any of the following notations. So we can use ARRA underscore AI. That implies value stored at ith displacement from base address of the array, that is ARRA underscore A. Right? So ARRA underscore AI basically refers to value stored at ith displacement from base address ARRA underscore A. So if this ARRA underscore A is initialized to pointer, then we can replace this notation with the pointer notation asterisk of PTR plus I. So this is very true. So it refers to value stored at ith displacement from base address PTR, where PTR is equivalent to ARRA underscore A. Now I can write 2 plus 3 is equals to 3 plus 2. So that means asterisk of PTR plus I can be replaced with asterisk of I plus PTR. Both are same, right? Okay. So if this is true, then I can also use I of ARRA underscore A, right? So all of these four notations refers to the same thing, that is value stored at ith displacement from base address of the array, that is ARRA underscore A. So you can use either of these four notations in order to refer to ith element of the array. Now likewise, in order to refer to ith value of ARR, we can use any of the following notation for the address, right? Okay, so for address of ith element of the array ARR A underscore A, we can use the notation ampersand of ARRA underscore AI, or we can use PTR plus I, or we can use I plus PTR, or we can use ampersand I ARRA underscore A. So any of these four notation can be used in order to refer to the address of the ith value of the array. So in order to access the ith value of the array, we can use either of these four notations, and in order to refer to address, we can use either of these four notations. So in today's class, what we have learned about is, we have learned about what is a pointer. We have learned that a pointer is a derived data type, and associated with pointer there are three types of concepts, which are pointer constant, pointer value, and pointer variable. Pointer constants are the absolute address allocated to the variable. Pointer value are the logical representation of the absolute address obtained using ampersand operator or the address operator. And pointer variables are variables that are capable of storing pointer value. Other than that, pointer variables can hold zero, null, and value of another pointer, provided that the type of pointers are same. We have learned about relation between pointer and simple variable with the help of an example where we have declared a variable, we have declared a pointer, and we have initialized the address of the variable to the pointer, and we have accessed the variable using the variable name, and we have accessed the variable using the pointer name as well. So if we access the variable using the variable name, it's called as direct memory access, and if we use pointer, then it's called as indirect memory access. Then we have learned about relationship between pointer and array, where we have learned that array name itself is a pointer value that marks the beginning of array definition in memory. And we have learned that these pointer value can be initialized to a pointer variable and can be used in order to access the subsequent values in the array. So we have learned that in order to access the ith element of the array, we can use either the array notation or the pointer notation, but both the notations basically implies the same thing. Even arra underscore ai refers to value stored at ith displacement from the base address arra underscore a, and we have also learned that ptr plus I basically refers to value stored at ith displacement from the base address, that is ptr. So we have generalized that in case of one-dimensional array, in order to access ith element, we can use either of these four notations, that is arra underscore a I, or we can use asterisk of ptr plus I, or we can use asterisk of I plus ptr, or we can use I of arra underscore a. So here it basically implies that this pair of square brackets are basically used as delimiters to separate the base address and the index only. Now, in order to refer to address of the ith element of the array, so we can use either of these four notations where we have introduced ampersand operator. So ampersand arra underscore ai, or we can use ptr plus I, or we can use I plus ptr, or we can use ampersand of I, arra underscore a. Now in the next class, we'll learn about relation between a pointer and a two-dimensional and three-dimensional array. Till then, thank you very much.